What's happening, geometry friends? So today we're looking at special types of parallelograms on the coordinate plane. We learned about all the properties of these special types of parallelograms, and now we're going to use the coordinates and slope to identify them and prove which one's which. Alright, so first I want to review some properties that these special types of parallelograms obtain. So, opposite sides are parallel. Well, that's one that exists in each one. Alright, all of these are parallelograms, therefore both pairs of opposite sides are parallel. So everyone has that. But now, consecutive sides are perpendicular. So that would mean that two sides come together to make a right angle. Well, we know that happens not in a parallelogram, not in a rhombus, but definitely in a rectangle and a square. Alright, and then the next one we're going to look at is diagonals are perpendicular. That doesn't happen in a parallelogram, that does happen in a rhombus, and that does happen in a square. Diagonals are not perpendicular. That is, they're not perpendicular in all parallelograms, and they're not perpendicular in a rectangle. So it's very important that we look at these kind of together. If you look, a rectangle and square share the property that consecutive sides are perpendicular. So after we get into our work, you're going to see, as I lay the groundwork for the next few problems, these two are going to kind of go together. Alright, and then I want to point out two differences in this. A rhombus and a square both have diagonals perpendicular. And that's not going to come to light until step 2 of our process. So, just a reminder of all these things that are happening, and we're about to put it all into play in a minute here. Alright, so let's give this a whirl. So, given the following coordinates, classify the following as either a parallelogram, rhombus, rectangle, or square. So, to begin, we're just going to draw a quick sketch. Now, we don't know if this is a parallelogram, we don't know if this is a rectangle, a rhombus, or a square, so I'm just going to draw kind of a general figure here, and then we'll go from there. Alright, so we're going to use slopes to test each side to determine if it's parallel or if it's perpendicular. Remember, if it's perpendicular, perpendicular slopes are opposite reciprocals. Alright, so perpendicular slopes are opposite reciprocals. So that's how we're going to be able to tell if they're perpendicular or just parallel. Reciprocals. Alright, so let's get into this. So let's look at the slope of AB to start. We have y2 minus y1 over x2 minus x1. So keep change gives me 5 over 5, which reduces to 1. Then we go, so we know that's 1. So now let's go CD. And we have negative 8 minus negative 3 over negative 2 minus 3, which gives me negative 5 over negative 5, which reduces to 1. So, alright, good start. We know opposite sides are parallel there. And now we're going to look at our next two, which is AD. So now we're looking at these 2 points. So negative 8 minus negative 7 over negative 2 minus negative 9. Keep change gives me negative 1 over 7. So we know AD is negative 1/7. Then we go to BC. And we look at those two slopes. So negative 3 minus negative 2 over 3 minus negative 4 gives me negative 1 over 7. Worked out beautifully. So, to begin, we do our first 4 slopes. Alright, and our first 4 slopes tell me whether I have a parallelogram or a rectangle. Alright, let's think about this. If both pairs of opposite sides match, we know we have a parallelogram if the slopes are congruent. However, if this was a rectangle, we knew these would be opposite reciprocals. So this would be negative 1/7 and this would be positive 7. Alright, or this would be 1 and this would be negative 1. Now that's not occurring here, so we know it's not a rectangle, and we also know it's not a square, because consecutive sides are perpendicular in both of those. So right now we know it's a parallelogram for sure, but it might be a rhombus, because a rhombus has opposite sides parallel as well. Now, we could do the distance formula to see if all these sides are equal, but that is a lot of work. With slopes, we can also tell the same thing, and it'll be proven true. So if we look up here, we're looking at the differences between parallelogram and rhombi, and we see that their diagonals are perpendicular. If the diagonals are perpendicular, we know for sure it's a rhombus. If the diagonals are not perpendicular, we know for sure it's a parallelogram. So step 2 of this process is to test the slopes of the diagonals. And again, if our slopes of our diagonals are perpendicular, we have a rhombus. If they're not, we have a parallelogram. So we're going to test AC and BD. Alright, so let's look at AC. And we have -3 minus -7 over 3 minus -9. So I get 4 over 12, which simplifies to 1/3. Now let's test BD. So I have -8 minus -2 over -2 minus -4. Keep, change. Gives me -6. Keep, change over 2, which is -3. So 1/3 and -3 are opposite reciprocals. So we know my diagonals are perpendicular. So a parallelogram with perpendicular diagonals is most specifically a rhombus. Alright, so if those diagonals were not perpendicular, we would have just had a plain old parallelogram. Alright, I know it's a lot to take in, but let's do another one. Alright, so now we're looking at example 2. Alright, so let's again draw a quick sketch just to give us a sense of what's happening. A, B, C, D. Alright, so let's start with AB. I have 10 minus 4 over -2 minus -10, which gives me 6 over, keep, change, 6 over 8, which is 3/4. And CD, we have -4 minus 2, -4 minus 4, keep, change, is -6 over -8, which is 3/4. Alright, good start. Now let's go AD and BC. So AD is, we're looking at this one and this one. -4 minus 4 over -4 minus -10 gives me -8 over 6, which is -4/3. That's interesting. And then we have BC. So BC gives us 2 minus 10 over 4 minus -2, which is -8 over 6, which is -4/3. Alright, so now we go and we look at what we're dealing with. So now we have 3/4 and -4/3. Do you see a special relationship between these two? We sure do. We know that they're perpendicular. Alright, they're opposite reciprocals of one another. So consecutive sides are perpendicular. So really, our shape looks like this, because we know we have right angles if our slopes are perpendicular. So if we have a shape with right angles, we know this has to be a rectangle or a square. It cannot be a perpendicular. It cannot be a parallelogram or rhombus. Alright, so it's a rectangle or square. So we know for sure it's a rectangle because it has 4 right angles. But if we had a shape with 4 right angles and perpendicular diagonals, then it would be a square. So right now we have an idea of what it is, but the most specifically we still have to test. So we're going to test to see if we have perpendicular diagonals. Alright, so again we're doing AC and BD. So AC is 2 minus 4 over 4 minus -10 gives me -2 over 14, which is -1/7. And then we're going to test BD, which gives me -4 minus 10 over -4 minus -2, which gives me -14 over -2, which is +7. So now if we look at these two, we have perpendicular diagonals. So a shape with 4 right angles and perpendicular diagonals is most specifically a square. All right, again, if these two were not perpendicular diagonal, so if I got like negative 1/7 and 1/8, the most specific name for it would be a rectangle because it would have 4 right angles but not perpendicular diagonals. So we use this process to test out the most specific name, and we use slopes to determine this. So pretty cool stuff here. All right, what I want you to do is pause the video, try the next one, and then we'll check our answers. So if you got a rectangle, then you are correct. When you test the slopes, we get negative 1/2 and 2, so they're parallel. However, they are also perpendicular because they're opposite reciprocals. So we're deciding between a rectangle and a square. So we test our diagonals, and we notice we get 3/4 and undefined. Those two are not opposite reciprocals, so we have a shape that has 4 right angles and not perpendicular diagonals. Therefore, it is a rectangle. All right, talk more about this tomorrow. Bye-bye.